Hello friends, in this video we're going to start a new paper of 2022 2022 C5 paper, Mathematical Physics, Dibrugarh University. Okay, so this is of 2022 third semester BSc Physics, and in the last video we have completed the paper of 2021. Okay, if you want to watch those videos, then the link of the playlist is given in the description box. And let me tell you one more thing, that those questions which are already solved, already I have video lectures on those questions. I'm not going to solve here. I will provide the link of those questions answers if I have already done in previous videos. Okay, so now let's start. Before we start, please subscribe the channel if you are new to my channel, and also hit the bell icon so that you get notified when new video will be uploaded. And if you like my videos, please hit the thumbs up button and share with your friends. So now let's start. So this is the first question. Here you see this question. This was asked in previous year also. Okay, so error function of x and complementary error function of minus x is equal to, its value is equal to actually 2, and 2 is not given here, so that's why correct answer is none of the above. Okay, so hope you have understood this. Now let's move on to the next question. Now next question is gamma function of half. We know that gamma function of half is root over pi, square root of pi. So this is the correct option. First option is the correct option, right? Now in the next question it is given that p twice m plus 1 is equal to what? P twice m plus 1 here of 0, that is equal to always 0. Remember that this is the correct answer. Let me show you how. So here we know that you see, if you have studied the special functions properly, then you must have got that you can consider summation z to the power twice n p twice m. So instead of taking m, let me take m instead of taking n. Okay, p twice m of x is equal to, we can consider this as 1 minus twice x z plus z square whole to the power minus half. You can consider that way. And if you put x is equal to 0, then you're going to get here 0, and this time going to be again 0, right? So that's why it reduced to 1 plus z square whole to the power minus half. That's what we're going to have. Sorry, yes, that is correct. Okay, now if we expand this, then we should get 1 plus then minus 1 by 2 into z square. Then we're going to have plus minus 1 by 2 into minus 3 by 2 divided by factorial 2 z square whole square, right? Z square to the power 2, right? And so we can expand. Okay, then we're gonna have minus half into minus 3 by 2 into dot 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 so on, and then we're gonna have minus half, minus n plus 1, minus n plus 1 divided by, this thing is divided by factorial n and z square whole to the power n, then plus dot 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 so on. That's how you can obtain this. So because you have already got this expansion 1 plus x whole to the power minus n, this is equal to nothing but 1 plus, right, 1 plus minus n x square, right? Sorry, not x square, only x, minus n x. Then you should get minus plus minus n into minus n minus 1, right, divided factorial n factorial to x square dot 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 so on. That is this expansion I have used here. Okay, so now let me cut it. Now here you see, when we have factorial 2 here, then this term, if you see this term, you can consider this one as minus half minus 2 minus 1. You can consider that way, right, when there is factorial 2. So when there is factorial n, that's going to be minus half, minus 3 by 2, and minus 5 by 2, dot dot dot, so on. Then at the end you must have got minus half, minus, when there was factorial 2, it was minus half minus within bracket 2 minus 1. Now it should be minus half minus n minus 1, right, within bracket. So if you open the bracket, then you're gonna get this term, right? And this is z square to the power n, and z square to the power n means this is nothing but z to the power twice n, right? Now compare the coefficients of z to the power twice, instead of n, let me write here m, okay, because in the question we have m here. So now let me write here m instead of m, let me use m, okay, to the power m. So then this is nothing but z to the power twice m. If you compare the coefficients, then you should get p twice m of 0, that should be equal to this term, right? So now let me copy this, you should get this, right? If you equate those, then you should get this. Let me write it properly, twice n, here m, now I am writing m here. So then this is factorial m, okay, so we should get this. Then if we simplify this, okay, then what we're going to have, so here you see, when there was factorial 2, here you can see there are two, this is a product of two terms. So when there is factorial m, right, that must be a product of, here in the numerator, that must be product of m numbers, okay, product of m numbers. So that's why if you multiply both the numerator and denominator by 2 to the power m, so here I have multiplied 2 to the power m here, and with the numerator also 2 to the power m, then you can cancel the 2 in each term, in the denominator of each term in the numerator. So you can cancel each 2, okay. So if you multiply each term by twice m on the in the numerator, 2 to the power m, and 2 to the power m should be multiplied to both numerator and denominator. Let me tell you. So I have multiplied here 2 to the power m, and here also 2 to the power m. So as there are m number of 2's and there are m number of terms, so we can multiply each 2 with each term. So hope you understood this. So and doing so, we're gonna have, and we don't know how many even number of negative terms or odd number of negative terms. So let me take here because we don't know the final answer going to be positive or negative, that's why we have taken minus 1 to the power m. If m is even, then it's going to be positive, otherwise negative. So and multiplying both the numerator and denominator by 2 to the power m, we have got this result, 1 into 2 into 3 dot 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 dot, and at the end we're going to have twice m minus 1, that's divided by 2 to the power m into factorial m. That's what we're going to have, right? So hope you have understood this. Now you see, but here you see, if you cancel those things, we are not going to deal with these things. In this expansion, so in this nth term here, in this mth term, you can see here the power of z is z to the power twice m, okay. When you go to the next term, after this next to this term, then you're gonna have twice m plus 2, right? So there is no z to the power twice m plus 1 term. In this expansion, this term will not appear. That means you can consider the coefficient of this is 0. And here, if you expand this, then here you see, as a sum of numbers, then one term you're gonna have z to the power twice m, p twice m of 0, and the next term you're gonna have z to the power twice m plus 1, then p, next time you're gonna have z to the power twice m p twice m plus 1, z to the power twice m plus 1, p twice m plus 1 of 0. And on the right hand side, here you see, if you see this, if you observe this carefully, then you can see that this term, in this term, just let me write it clearly. So here you see, just wait. So this is factorial 2. Here you should get minus 3 by 2, then here it is minus 1 by 2 into dot dot dot, we have got here minus half, then minus m plus 1. That's what we had got here, factorial m, right, into z to the power 2 whole to the power m. So in the next term, this variable will be appear as 2 to the power twice z to the power 2 whole to the power m plus 1, right? So when you get that, then you're gonna get in the next term this, you're gonna get z to the power twice m plus 2. That's what you're gonna have. So because you see, just wait, z to the power 2 whole to the power m plus 1, when you write that, next term of this number, so this term next to this term, you're gonna get this. So then if you multiply 2 here, then you're gonna get this. So we are getting these two terms. We are getting z to the power twice m, then we are getting z to the power twice m plus 2, but we are not getting z to the power twice m plus 1. So we can consider that, we can say that coefficient of z to the power twice m plus 1, coefficient of z to the power twice m plus 1, as we are not getting any term where the power on z is twice m plus 1, so we can consider the coefficient as 0. So on the left hand side, we're gonna get p twice m plus 1 of 0. This is the coefficient of z to the power twice m plus 1, because you see, the coefficient of z to the power twice m on the right hand side is p twice m of 0. So definitely, if there is summation, then the next term should be z to the power twice m plus 1 p twice m plus 1 of 0, right? But on the right hand side, we are not getting any term whose variable is z to the power twice m plus 1. So that's why it must be equal to 0. So hope you have understood this thing, how I have got 0, right? So the correct answer is this. Now in the next question, here you see this function e to the power 2 tx minus t square. This is the generating function of what? This is Hermite polynomial. This is the generating function of Hermite polynomial. No, right? So question 3 is the option 3 is the correct. And if you want to know the Bessel's polynomial, generating function of Bessel polynomials, let me write here. Okay, it may be also asked. Bessel's polynomials, its generating function of Bessel polynomial is e to the power x by 2 into t minus t to the power minus 1. Right, let me write it properly. E to the power x by 2 into t minus t to the power minus 1. That is the generating function of Bessel polynomial. And let me write the Lakhyajit polynomial, generating function of Lakhyajit polynomial. Okay, generating function of this polynomial is 1 by 1 minus t e to the power minus x into t divided by 1 minus t. That is the generating function of Lakhyajit polynomial. So hope you have understood this. So now let's move on to next. You see 1e. So Fourier series representation of an even function. So in case of even function, the consist of cosine terms only. Okay. So if you expand, if you obtain the Fourier representation of an Fourier series representation of a given function which is even function. If it is even function, then its Fourier series should be in terms of cosine only. Okay, cosine only. And if it is odd, odd function, then the terms of that Fourier series must consist sine terms only. Okay, for odd function, it consists only sine terms, and for even function only cosine terms, right? So our correct option is 3. So hope you have understood this. Now question number 2a, describe the complex form of Fourier series. So here you see, for the description of complex form of Fourier series, so you can watch my lecture number 9 of Fourier series. Okay, Fourier series lecture number 9. I have given the link in the description box, that complex form of the video title is something like this: complex form of Fourier series, lecture number 9. Okay, lecture number 9, you can watch that. I have given the link in this way: question number 2a answer, and I have provided the video link here. Okay, so click that, then you're gonna get the answer. And for this next question number 2b, for this question also I have already solved in my lecture number 2 of Fourier series, question number 2b, and I'm gonna provide the video link here. Question number 2b answer, video link will be provided here in the description box. So that is most probably Fourier series lecture number 1. Okay, in that video you're gonna get the answer, right? So now let's move on to next question. Now let us solve question number 2c. So this is the function f of x. When x is greater than 0 and less than half, it is 1, and when x is between 1 and half, then it is 0. Okay, now this is the solution here, you see. So this is the function, given function. So here given function is f of x, which is equal to 1 when x is greater than 0 and less than half, right? Okay, then so hope you can see this. Then f is equal to 0 when x is greater than half, and less than 1, right? So now then we have considered the Fourier series of this function f of x is this, so which is a0 divided by 2 summation n is equal to 1 to infinity, right? N is equal to 1 to infinity. This is an cos n pi x by l. This is l, right? And this is summation n is equal to 1 from infinity 1 to infinity bn sine n pi x by l, right? N pi x by l, right? This is x by l. Just wait, right? So now here you see the difference of this the lowest and the highest limit. The difference is 1, and 1 should be considered as twice l, right? And doing so, we have got twice l is equal to 1, so l is equal to half, right? L is equal to half. That's what we have got. Now let me write this one properly. So what we have got twice l is equal to 1, so l is equal to half, right? Now f of x, so if we replace this this l and this l then we're gonna get this, right? This is the series. Okay, so this L is replaced by half. Then what you gonna have? Then you're gonna have A naught by 2 summation n is equal to 1. So hope you can see this. This is A naught by 2, right? A naught by 2 plus summation from n is equal to 1 to infinity. This is A n cos twice n pi x, right? Plus again summation from n is equal to 1 to infinity bn sine twice n pi x. That is what we're gonna have, right? So let me write this one properly. If you cannot see, just wait. So what we're gonna have? We're gonna have this f of x a naught by 2 summation plus summation from n is equal to 1 to infinity a n cos n pi x. Sorry, on putting this L is equal to half, so it's gonna be 2n pi x. Similarly, summation n is equal to 1 to infinity bn sine twice n pi x. That is what we will get. And let us consider this is equation number 1. Okay, let us take this as equation number, okay, this one is taken as equation number 1. Now you see, this is a naught is equal to 1 by L integration from 0 to twice L, right? 0 to twice L. This is f of x dx, right? F of x dx. Now here you see, just replace this L by half, right? This value of L, okay, this there is twice L, so replace this L by half, then 2 gone, then you're gonna have, what you're gonna have here, you're gonna have 1 here, right? So this is this 1 by L, so 1 by L is replaced by half, then it's gonna be 2, right? So that is why here we have got 2 integration from 0 to 1 to infinity f of x dx. That is what we have got. And here you can see that, so now let me clean this. Here you can see that this f of x dx is there are two values, is 1 when x is between 0 and half, and it is 0 when x is between half and 1. So that's why we have expressed this integral. So we have expressed this as a like this, is equal to 2 into integration from 0 to half. Okay, so instead of writing 0 to 1, we have split it into two terms, 0 to half, then half to 1 f of x dx. But half to 1 when x is between half and 1, then f of x is 0. That is why you see these terms become 0. That's why this terms becomes 0, 2 into 0. So that means it's gonna be 0, right? So that's it. So here 1 into dx, right? So integrating dx, we gonna have here x, right? 0 to half. So here we have 2, right? So on putting the upper and lower limit, here we have got half, 2 into half, and 2 to cancel. That's why we have got 2. So this is the value of a naught, right? This is a naught. So similarly, we can find an is equal to 1 by L. So this is 1 by L. So integration from 0 to twice L, right? This is f of x and here we have cos x n pi into x by L dx, right? So similarly, if we replace the L is equal to half, then we're gonna get this is equal to half 2 into 0 to 1 integration f of x cos twice n pi x dx. That is what we're gonna have, right? So hope you have understood this. So what I have written this is nothing but 2 integration 0 to infinity f of x cos 2n pi x dx. That is what I have written here. Now you see, again you can see that we can split it from 0 to half, then half to 1, which is gonna be again 0. So that's why we have got only this. And when you integrate f of x from 0 to 1, f of x is equal to 1, so 1 into cos 2n pi x dx. That is what we have got into 2, right? So now this is 2 into integration from 0 to half. This is what? Integration from 0 to half. This is 1 into cos twice n pi x dx. So, and when you have got 0 to, sorry, not 0 to pi, half to 1 f of x cos twice n pi x dx, then half to 1. Here you can see when it is half to 1, when x lies between 0, half and 1, then this f of x is 0, right? So hope you can see it clearly. So that's why we have put this one is equal to 0, right? So hope you have understood. That's what we have got. So that's why I have written here 0. So this is the result we have got. And if you integrate 0 to half, here cos 2 n pi x dx, then you should get sine twice n pi x divided by twice n pi, right? And here it is we are integrating it from 0 to half. Then putting the upper and lower limits, we have got this result. We have got here you see 2 to cancel, half of 2 to cancel, then we have got 1 by n pi sine n pi, right? Sine n pi, and sine n pi is equal to 0 where if n is integer. So that is the value of an. This is the value of an. Now similarly we can find the value of bn as well. So bn, so here again 1 by L, this is f of x, right? This is f of x, integration from 0 to 2L, right? Integration from 0 to 2L. This is f of x sine n pi x by L dx. That's what we're gonna have is equal to, again if you replace L by half, then you're gonna get this result. This is nothing but 2 integration 0 to L f of x sine 2n pi x dx, right? Let me write it clearly. So this is what integration from 0 to 2 into integration from 0 to 1 f of x sine 2n pi x dx, right? So again you can split this one as 2 into 0 to half f of x sine of this one plus again integration from half to 1 f of x and sine of this one, and this term gonna be 0. When you gonna integrate from half to 1, that's gonna be 0 because f of x is 0 here. When x is between 1 and half, then f of x is 0, right? So that's why this part will gonna be 0. That's why what we're gonna have here, that's why here you see, that's why I have written here 0, so this is bn. That's why I have written here this is 0. When you integrate the function from half to 1, then it gives 0, right? So hope you have understood this. So now, so here 2 into 0 to half 1 into sine twice n pi x dx, that is what we have got. Now if you integrate this, sine twice n pi x dx, integrating this, what we're gonna have, we're gonna have minus cos twice n pi x by twice n pi, right? Here I have written this one, so hope you can understand this, right? So this is 2 pi n and 0 to half, so here 2 to cancel, and here you see, again here you see, just let me show you one thing. Again, if you replace this x by this half, right, that means if you upper limit and put the upper limit and lower limit, then what you're gonna have. So now you see, just wait, let me clean these things. Okay, these are wrong, this part is wrong, so I made a mistake here. Okay, let me do it again. So here you can see, so when you put here, let me write this one clearly. Okay, just wait, give me a second. Okay, so when you integrate this to integration of sine twice n, this one, right? So here we had, this is half, and here we had 1 into sine 2n pi x dx, that is what we had, right? If you integrate this, then what you're gonna have, you're gonna have minus cos twice n pi x by twice n pi, right, from 0 to half, right? So when you're gonna put half here, when this x will be replaced by half, then these two will be cancelled with that, and these two cancel. So we're gonna have here you can see, so just wait, so we're gonna have minus cos n pi, then minus, and minus plus cos 0 degree. When you're gonna put 0 here, then you're gonna get 0 here. So right here, so cos 0 is 1, and cos n pi is this, right? Cos n pi is minus 1 to the power n, and cos 0 is 1. That is what we're gonna have. Now let's put the value of this is bn. Now putting the values of a naught, an, and bn in equation number 1. So what was the equation number 1? So here you can see this is the equation number 1, right? Let me go to the new slide, and let me write the equation number 1 again. The equation number 1 that we had is a naught by 2 plus summation n is equal to 1 to infinity cos twice n pi x plus summation from n is equal to infinity bn sine twice n pi x. That's what we had. Now you see, we have got a naught, this a naught is equal to 2, right? We have got a naught is equal to 2, we have got a naught is equal to 2, and an is equal to 0. Here you can see we have got an is equal to 0, here this is 0, and bn is equal to this is the value of bn, and bn we have got minus 1 to the power n minus 1. That's what we have got, right? So you can take the minus common, then you're gonna get minus 1 whole to the power n plus 1. That's what we're gonna have, right? So now you see, so if you put a naught is equal to 2 here, these two cancel, so we're gonna have 1 here, so this is 1, and an is 0, so simply this term gonna be vanished. Okay, this is gonna be 0. So then here bn should be, here you see n is equal to 1 to infinity, bn in place of bn, so there is minus sign, so you can replace this one by minus, then here you're gonna have minus 1 whole to the power n plus 1 into sine n pi x. That is what we're gonna have. Now putting n is equal to 1, what we will get, we're gonna have, right, summation n, on putting n is equal to 1, if you put 1 here, then this is going to be minus 1 plus 1 cancel, so that term going to be 0, right? Now if you put 2 here, if you put n is equal to 2, then this is going to be plus 1 plus 2, then you're going to have 2 sine 2n pi x. Then again if you put odd number here, that's going to be minus 1 and it's going to be cancelled with the plus 1, so that's why here you see next term will be 0 when you put 3, 5, 7 odd numbers. On putting odd numbers, this term will be minus 1 which can be cancelled by plus 1, so then in those cases we're going to get 0. So if you put even power, so once we have put 2, we have got this one. Now let's put here 4, 6, 8, and in those cases you're going to have plus 1 2, so you're going to have again because of this minus sign, again you're going to have minus 2 sine n pi x. Then again so here it's going to be, on putting 2 we should get here 4, and on putting 4 here we should get 8, right? It is going to be 8, right? And on putting 6, then minus 2 sine, that's going to be here on putting n is equal to 6, that's going to be 12 pi x, and so on. That's how we're going to proceed. Okay, so this is the result. So hope you have understood this. Now let's move on to the next question. So here is the next question. Determine whether x is equal to 0 is an ordinary point or singular point of the following equation, of this equation. Okay, so now let me go to the solution directly. So here is the question number 3. This is the given equation. Here we need to check, is x is equal to 0 ordinary point or not. So on here you see this is the coefficient of y double dash, which is regarded as p of x, and coefficient of y dash is taken as q of x, and this part is coefficient of y is taken as r of x. So here p of 0 is 0, that's why the definition of ordinary point is x is equal to x naught is said to be ordinary point of a given equation if p of x naught is not equal to 0. But here we are getting it is equal to 0, so that's why x is equal to 0 is not ordinary point, so it must be a singular point. So there are two kinds of singular point, one is regular and one is irregular, right? So to be regular, these two conditions must be satisfied. So taking limit from x to 0, because we are doing it for x is equal to 0, x into q of x divided by p of x. You can see, hope you can see this. Then let's put q of x is this 7x plus 7x into x plus 1, so I have put here, and p of x is twice x square, I have put here. This x cancelled by x square, right? So here you can see clearly x into x square, which can be cancelled by this x square. Then we're gonna have this, right? So x tends to 0, so that's why if you put here 0, then you're gonna get this answer, right? So that is finite, so limit exists. So now again limit from x tends to 0, here x square, again taking r of x, here r of x is equal to minus 3, so let's put here minus 3, so this is x square, and divided by p of x is this 2x square, so here we have 2x square, right? So x square cancels, so we have here minus 3 by 2, which is again minus 3 by 2, which is also finite. So we can say x is equal to 0 is a regular singular point. So hope you have understood this. Now let's move on to the next question. So here is the question number 3b. So this is the question, right? We have to solve any one, but I'm going to show you both. So here you see this question I have already solved in Frobenius method lecture number I think 3 or 4. So I will provide the link in the description box. let's check. I'm going to provide this one as this way. Question number 3b answer, and I'm going to provide the video solution, video link. Okay, so then you're going to get the answer. Now let us solve this equation. Okay, so now let's go to the next slide. Okay, what is the equation here? So here you see this is the solution of this equation, question number 3b number 2. So here I have considered the solution as y is equal to this, right? So hope you can see, and once we have differentiated, we have got y dash equal to this one, right? And again differentiating this, we have got y is equal to this one. So here you see, can you recognize this? This is what? This is y double dash. Y double dash is your this one. Y double dash is equal to, let me show you here, summation r is equal to 0 to infinity a r m plus r into m plus r minus 1 x to the power. So let me write here x to the power m plus r minus 2. That's what we have got. So hope you have understood this. So if you are watching my videos, if you are watching my videos, you know, continuously, that means if you have watched my videos on Frobenius method, I don't think I need to explain this solution. Just you need the solution, then just know it. Okay, so what I have done, so I have put the expressions of y dash and y double dash in equation number 1, and doing so we have got this expression, and then I have simplified this expression. So here what I have done here, you can see in this case I have taken this part common, right? Just wait. Here you see this x is multiplied with this one, so I have got x to the power m plus r minus 2 plus 1, which is gonna give you r minus 1, right? So this is also x to the power r minus 1 here, x to the power m plus r minus 1, and this is also x to the power m plus r minus 1, which can be taken as common, and taking that common here, we have got this, and also we have taken this part also common, summation a r, right? And within bracket we have got this 4 m plus r into m plus r minus 1 plus twice m plus r. That is what we have got here, twice m plus r, right? So that's it, what we have done, right? So similarly, again what we're going to do here from this, if you simplify this, then you're going to get this expression, and just wait, let me write it properly. So this is x. Okay, so now what we're going to do, equating the coefficients of x to the power minus n, lowest possible power of x, that is x to the power minus n. So in order to get x to the power minus m, here we need to put r is equal to 0, then you will get m plus 0 minus 1, then you're going to have m minus 1, right? And here we have m plus r, so in order to get m minus 1, we need to put r is equal to minus 1, but r is equal to 0 to infinity, so r is always positive, that's why we cannot put r is equal to minus 1. Okay, so that's why we're going to ignore this part, so we're going to take this. So, and putting r is equal to 0 here, r is equal to 0 here, and here also 0, we have got this. Okay, and solving this, we have got m is equal to 0, or this m is equal to 0, or we will get twice m minus 1 is equal to 0, because a naught is not equal to 0, right? So here we have got the two roots, one is m1 which is 0, another is m2 is equal to plus half, and they are not equal, these two are distinct roots, and they are differ by an non-integral number, that is half, they are differ by a fraction number. Okay, then again equating the coefficient of x to the power m plus r minus 1 to 0. So in order to equate that, we need to replace the r by r minus 1 in second summation. So first here you see, when we have equated this coefficient of when we were equating the coefficients of x to the power m minus 1, then we put r is equal to 0 in the first summation. Now we have to put r is equal to r minus 1, r should be replaced by r minus 1 in the second summation. If you replace this in the second summation, m plus r is replaced by r minus 1, then here you see power on x in this term and in this term, both become same, and then we can take the coefficients equal to 0, right? So then we have taken this coefficients is equal to 0. So what I have written, this is nothing but AR, this is your AR, and this is here you can see this one is AR minus 1, right? This is AR minus 1, this is AR minus 1. So hope you have understood this. And simplifying this, we have got AR. Now let's find A1, A2 and A3. Hope you know how to find those things. So if you have solved these kind of problems, and if you have I hope you have been watching my videos. If you are watching my videos, then you should know how to simplify and how to obtain those values, right? Just to let me tell you again, here you see. So here on putting r is equal to 1, we have got A1. So here if you put r is equal to 1, that's going to be A0, and we have got A1 is equal to this. Then again A2 will be equal to just wait, this A2 will be equal to this one, right? Minus A1 is equal to 2 into m plus 2 twice m plus 3. Okay, so on putting r is equal to 2, we have got this. Again you can put the value of A1 here. This is the value of A1. If you replace this A1 by this value, then you're gonna get this result, right? Similarly you can find A3, A4, so on, right? Now let me go to the next slide. So this is A3, right? So now why we have considered summation from r is equal to 0, summation from r is equal to 0 to infinity, and so we can write the y as ym like this, for m is equal to m. So ar is equal to x to the power m plus r, that is what we have written, and this can be expressed as a0, putting r is equal to 0, 1, 2. So we have got this series a0 x to the power m plus a1 x to the power m plus 1 plus a2 x to the power m plus 2 plus dot dot dot, so on, right? So now if we put m is equal to m1 means in the sense m1 is our 0. Here you can see the one root if we put, then also if we put the values of a1, a2, a3 as a0, a1, a2 and so on, right? Then we will get y m is equal to m1. This is what y m is equal to m1. m1 means m1 is equal to 0, and putting 0 here we're gonna get this solution, right? So what we have done, we have put m1 is equal to 0, and also we have put here the values of r from r is equal to 0, 1, 2 dot dot dot, so on, and putting those we have got this series. So x by 1 into 2, then x square plus x square, so 1 into 2 into 3 into 4, then next x cube minus x cube, 1 into 2 into 3 into 4 into 5 into 6, right, and so on. That's how we can proceed, right? So here you see this x can be written as root over x whole square, right? X can be written as root x whole square. Similarly x square can be written as root x to the power 4. So this is root x to the power 4, right? Similarly x x cube can be written as root x to the power 6 and so on, right? So that's how we have got this series. Here you can see what we have got, 1 minus here we have got a0, this one a0 1 minus root x square by 1 into 2 minus, sorry, not minus, plus root over x whole to the power 4, 1 by 1 into 2 into 3 into 4, then minus root over 6 whole to the power root over x, so root x whole to the power 6 by 1 into 2 into 3 into 4 into 5 into 6 and so on, right? And this series is given by cos root x. This is the series of cos root x, okay? So we have got a0 cos root x, So this is what we have got, one solution. Similarly, we can find ym2. ym2 is equal to m2 is equal to half, right? If we put the value of half, then we're going to get this series, right? So here you see, let me write it properly. This is m2, which is equal to half. So if we put here, instead of m, if we put m2 is equal to half, and putting r is equal to 1 2 3 0 1 2 3 and so on, and if we will put the value of a not a1 a2 and dot 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 so on, then we're gonna get this series. Okay, so and this series is given by sine root x, right? A naught sine root x. And you see, when the roots are distinct and differ by an fraction, if this difference doesn't belong to integer, so then the solution is given by this one. So if we put ym1 ym2 here, we have put this is ym1 and ym2, this is ym2 here, then we have got this relation. Okay, and you can write this c1 a naught as a and c2 a naught as b. These two are nothing but constants. Okay, then you're gonna get this answer, right? And if you want to keep the answer this way, that means instead of putting cos root x and sine root x, you can keep this answers. You can express this answer as a you can write in place of ym1, you can write this series directly, and in place of ym2, you can write this series. Okay, then also you can express your answer. Okay, it is not necessary that you must have put this 2. Okay, so hope you have understood this. Now let's move on to next question. So I'm going to solve the remaining questions in the next video, in the next part, in part 2. This is part 1, right? In the next part we're going to solve. It is coming soon. After 2 or 3 1 or 1.5 hours you may get the part 2. Okay, so before 9:30 or 10 p.m. between this time interval, you're gonna get this today. Okay, so now let me stop here.